Hello, everyone. My name is Jared McFoy, and I'm using unmanned aerial vehicles to create 3D models of rock outcrops. I used photogrammetry to create this 3D model, specifically Agisoft Metashape, and while it worked, there are a few things that could have been done better to make a better model in the end. So, first up, my study site. My study site is located in Jane, Missouri, which is about 2 hours away from Springfield. And my target feature that I modeled is a carbonate mud mound for my thesis project. And these carbonate mud mounds are basically rock outcrops on the side of the highway. So they can sometimes be difficult to image on foot because they can be 20 to 60 feet above the highway because there's these specific features on a wall of rock that's could be up to 100 feet tall. But to kind of solve the problem of these things being off the ground by 20, 60, however many feet, I used an unmanned aerial vehicle, a UAV, or a drone, as they're also called, to kind of take pictures to create this 3D model. And I also used some ground images on to get some better pictures of it too. So that way I got kind of every single side. So if you're not 100% sure where Jane is, I have a little map. Here's Springfield, and down here is Jane, along with a bunch of my other study sites. This mound is specifically that red dot all the way in the bottom corner down here. So kind of my methods, how I did this was basically all my data was primarily photos. These mounds are kind of small in size and area. And we could do a LiDAR scan. They have been done. We did one specifically with a iPad 12 and used their LiDAR scanning app to make a sort of scan. But I wanted a 3D model that I could annotate and had kind of the um, visuals of the rocks on it. So you could kind of tell, okay, this is where this thing is, and this is what color it is. So to do this, take these pictures, we imaged it with a panorama feature on a UAV, DJI Mavic Air, and then additional pictures were taken by a high-resolution DSLR camera. Then all these pictures were imported to Agisoft Metashape. We had about 74 pictures that got used in the end out of a few hundred. And then to create the model, I followed the USGS workflow along with what we did in class to kind of create a full model. And if you're not familiar with it, here it is. It's kind of a 10-step program to kind of be like, here's how you make it. After aligning all the photos and everything, the big parts is the part 10, whereas you build the dense cloud, you build a mesh, you build a texture. I didn't build a DEM or Ortho mosaic because I didn't really need it. I didn't really have this thing is not that large in scope, so I just built the texture. But you could build DEM and Ortho mosaic if needed. So here's the model. This is the complete model. You can kind of see, and there's a couple different angles. And at the end of this presentation, you'll be able to download a copy of it on a PDF. But overall, I think this one came out really well. This is the jelly roll mound is what we call it. And it's kind of a perfect mound for this project because it had multiple faces exposed to the surface as opposed to just one face that you can really see. And modeling it worked. It went okay. There were a couple of issues. As you can see kind of here, there's a little gray spot that didn't really photo right, but important features like the jelly roll here and this little shaly bit and a couple of the cracks in the rocks worked really well. So on a full view, you can zoom in and see what you're looking at. But the top of the mound didn't model correctly. There was issues with pictures referencing each other and kind of making a cohesive whole. So that caused a couple of problems, but I got really the front side, which is what I needed for my work. And one other issue that you might see if you've been looking down in this corner down here, the bottom left corner, is the axis. It modeled upside down, which really isn't a big issue because in the end I have a fully functioning model, but it's kind of weird if you open it up and it's at some weird off angle. Just know that this is kind of the front of the mount. So kind of after making the model, we got kind of what went well, what didn't go well. So overall, the model worked. That was a good thing. I had multiple weeks of trying to get this thing to work, and finally, I got it working after being super finicky. And then it can be viewed in 3D. And now that's really useful for me because I can use this to present it to different people, and I can make models of other mounds in the area. And also small details can be seen on it as well, which is important for kind of geological analysis. That'll be especially important when we're trying to determine the age and the sort of origin of these carbonate mud mounds. But not everything worked, so I got some things that I thought I could be doing better in the future. So first up, not all photos could be used. Like I said, I got about 74 photos working in the end, and the top of the mound didn't render properly. And that was because some of the photos at the top didn't reference each other correctly, or uh, yeah, were taken at different zoom levels. And Edgesoft Metashape doesn't like different zoom levels. Another thing is we need to use more UAV work to map all the mountains. This was done with a UAV panorama and a ground DSLR camera, but if we use the UAV to get every side of it in a more systematic method, it would work a lot better. This was a kind of we went out, we took pictures, and we went back to see if it worked correctly, and it did. So in the future, we're going to be using a few more UAV work. We're going to be taking pictures from all different angles. And then the last one I kind of said was the kind of the processing workflow may need to be refined in the future. Um, some of the issues I use the USGS workflow, but some of their things they say like use the dense point cloud to create a mesh and all that didn't work for me. It took forever to process and then didn't process correctly in the end. So I used depth maps to create my mound, and it worked a lot better than the other options. And in the future, I might need to make a DM and orthomosaic, but in this situation, it's not really that needed. But so thank you for listening to me today talk about my model. But if you want to access this model yourself, you can go to this link and it'll be down in the description below. And you're going to want to open an Adobe Acrobat and trust the document. There's a thing that pops up that says options, and then click on the question mark if it doesn't load. I found that Adobe Acrobat's the only thing that really works. It works well for modeling. So if you want to look at it yourself and kind of see, oh, here's where things went well, here's where things didn't go well on your own, here's where you do it. And if there's any questions, you can email me at my email here, jwm1809@live.missouristate.edu, and I'll be able to answer anything. And here are my references for the USGS's workflow and how they made structure for motion photogrammetry. Thank you for listening to me today.